Hello, welcome to Taxonomy Online Mathematics. We are still having a continuation of our lesson on integration, and under this episode, we'll be taking the area under a curve, which is more or less integration of definite integrals. If you ask to find the area under a curve, you are only asked to find the area enclosed by the graph, the area enclosed by the function, and that of the x-axis, particularly giving some coordinates on the x-axis. If you are new, consider subscribing to the channel, like, share, and comment. Let's get into it. Now, if we are asked to find the area, we know that we can be given a linear function to integrate. We can be given a quadratic function to integrate. We can be given polynomial with a higher power. So if in case we are taking the first as, let's say, y equals to, let's say, 2x plus 3, we want to find the area enclosed by this graph and the x-axis spanning from, let's say, x from 1 to what? 4. From 1 to 4 simply means that your lower limit is 1 and the upper limit is what? 4. So that simply means the integral from 1 to 4 of y dx. Similarly, from 1 to 4, y is what? 2x plus 3 dx. If I'm able to find the definite integral of this, then I am as well as finding the area that is enclosed by the graph. So this is going to be increasing the power, plus 1 will give us 2. So if I divide by 2, the 2 will go. So I'll be having x squared plus 3x. If you integrate the constant, your variable is introduced. The integral from 1 to what? 4. So from the upper limit, I have 4 squared, 4, minus the lower limit, 1 squared, 3 times 1. I believe this will be 16, this will be 12. So 16 here plus 12 minus 1 plus what? 3. I think this will give us 28 minus 4. So we're having 24 square what? Unit. I'm adding the square unit because I want to find the area under this curve. So the area under the curve is this, which is more like the same as finding the definite integral. Simply put, we just go ahead and make a sketch of that. If you want to start in the sketch, we know if x is 0, y is going to be 3. So imagine x is 0, y will be somewhere here, what? 3. If x is 1, y is going to be 5, which means there will be a point here. If x is 2, y is going to be 7. You see that as x is increasing, y will also be increasing. So I'll be having a straight line. So we know, because this is a linear, a straight line passing through the point what? 3. We are looking for the area enclosed by this line, which is now the curve, and the x-axis between the coordinate of what? 1 and what? 4. I can have 2, 3. So 1 and 4. So this is the area. The shaded area we are looking for. What is the area shaded here? And that area is what? 24 square unit. How do we get that? That is the integral of what? The line, which is going to be y equals to 2x plus what? 3. So basically, finding the area under a curve is just performing a definite integral. Good. We are seeing this as a straight line. So we have this calculation. What if it is a quadratic equation? We are going to have what? A parabola. Either it is going to pour water or it's going to hold water. So for example, so let's consider the equation y equals to 4 minus x squared. So we are asked to find the area enclosed by this function, and the x-axis spanning from 0 to what? 2. What I mean is that lower limit is 0, upper limit is 2. You are aware that this is going to be integral of y dx spanning from 0 to what? 2, which is the integral from 0 to 2, 4 minus what? X squared dx. So right here you know that definitely we are going to perform the definite integral. Whatever answer we get becomes our solution. So I'll begin with the sketching of the graph or the curve. We know that if x is 0, y is going to be what? 4. So 0, 4. If x is 1, we are going to have the value of y become what? 3. It will decrease. So this 0, 1, it will decrease. If x is 2, if I put 2 here, I'll be having what? Y to be 0, 4 minus 4. So it means it will decrease to this place. The same way, if we have a negative values input here, the graph is going to cut here, here, and negative 2. If I put negative 2 here, because this is going to be negative 2 square, that will be 4. 4 minus 4 will give me y to be 0. So your curve is going to be, pardon me, this is my curve. Good, that's my parabola. Because the x squared is negative, it will pour water in this way. Now, what is the area we are looking for? The graph, or y equals to 4 minus x squared. This is our x-axis. Are we going to shade all the region enclosed? No, we are shading from where? 0 to 2. We know this is the origin. So we are looking for the area enclosed here. We are looking for the area enclosed between 0 and 2. If the question is the same and the limits are from negative 2 to 2, it means we are finding the whole area enclosed. The whole area enclosed by the graph. So now we can now integrate, knowing very well where we are looking for. This is going to be, we will increase here by the variable x, increase this power by 1 to become 3, we divide by that. So minus x to the power 3 over 3 from 0 to 2. So putting the upper limit, I'll have 4 multiplying 2 minus 2 square over 3. Don't forget this will give you 0 back. Let's indicate it. 4 times 0, 0 to the power 3 over what? 3. All of this will be 0, alright? I think this is the power 3. This will be giving you 8 minus 8 over 3. So if you have our, don't forget this is going to be minus 0. What will be the LCM? 3. So 24, as in 1 go here 3 times, times this 24, minus 1 go here 1 times this 8. So what do we get? I believe we take away 4 from here, we are left with 20, another 4, so 16 over 3, that will be 5 whole number, 1 over 3 square what? Unit. So in this case, the area enclosed by the graph and the x-axis and the coordinate 0 to 2 is just going to be 5 point something square unit. I believe we are getting the steps. So finding the area we are finding so far are all above. They are all above what? The x-axis. All areas above the x-axis give you a positive value. But if in case you calculate and get a negative answer, that simply means that your area is dropping below the x-axis. Let's take example. Okay, let's consider our equation to be x squared minus x. area enclosed by this equation and the x-axis from, let's say, 0 to what? 2. Let's see the curve. If x is 0, I'll be having y to be 0. So it means the first point is going to be here. Now, if I put x to be 1, the moment x is 1, I'll still get 0. So let's say x is 1, I'll still have a point to be 0 here. If x is 2, don't forget 2 will be 4. Here will be 2. So 4 minus this will be 2. So I'll be having 2 here, 2 there. So there will be a point here. It will climb up. And the moment this is having a positive coefficient, our parabola is going to hold water. So it means it will cut the x-axis here, bend down and go up. But we are looking for the point between 0 and 2, so I can put my 2 here. So we are having 3 areas here to find. Area here between the curve and the x-axis, area here between the x-axis and the curve, area here between the x-axis and the curve. But our coordinate is spanning from 0 to 2, meaning from only here to here. So the area we are looking for will be here. Below, above. I explained earlier on that if we have area below the x-axis, that gives you a negative value. Area above is a positive value. So in this case, we are going to find the area of this plus the area of this. Or we are going to just say, I'll be having integral of the point. I'm having the upper. So upper will be from 1 to 2y dx minus the integral of the lower 0 to 1 y what dx. Don't forget, it's the same function that we are going to integrate. It will be different from integrating all the way from 0 to 2, as in 0 to 2. This is different from that, because this is having a below and having what? Above. So in this case, I have integral from 1 to 2 x squared minus x dx minus integral 0 to 1. Then I have what? X squared minus x dx. I believe if you increase this, we are going to have 3. So divided by 3. If you increase this, we have 2 divided by 2. The same way. So I'll be having x to the power 3 over 3 minus x squared over 2, which is going to be from 1 to 2 minus, I still have x to the power 3 over 3, x squared over 2, spanning from where? 0 to what? 1. Let me take this with the upper. So we're having 2 exponent 3 over 3 minus 2 exponent 2 over 2. All this minus the lower limit, 1 exponent 3 over 3, 1 exponent 2 over 2. Don't forget, I'm taking only the first one. So this will be 8 out of 3 minus 4 out of 2. That will be 2. Minus 1 out of 3 minus 1 out of what? 2. Alright? So I believe this will be having LCM of 1. So this will be 6 times this will be 3. So 6 over 3. And this is going to be 8 minus 6. That will give you 2 out of 3 minus this will multiply this to give you 2. This will multiply to give you 3. And if you multiply, then you get 6. So I'll be having 2 minus 3. That will be negative 1 out of 6. if you remove the bracket, you'll be having 2 out of 3 plus 1 out of 6. So if I multiply here by 2, I have the same denominator. So 2 here, 2 here. Become 4 out of 6. 4 plus this will give you 5 out of what? 6. That is for only the first part. Then we take the second part. That is going to be 1 exponent 3 over 3 plus, I think this will be minus. So we have minus 1 exponent 2 over 2. We are going for lower limit, which will be 0 exponent 3 over 3. 0 exponent 2 over 2. Obviously, it will be 0. So this will be 1 out of 3 minus 1 out of 2. This time this will give you 2. This will give you 3, right? So we're going to have minus 1 over 6. We are having a minus here. So this value minus this. So 5 out of 6 minus 1 out of 6 give you 5 out of 6 plus 1 out of what? 6. Since they have the same denominator, we add the numerators. That gives us 6 out of 6, which will be 1 word square unit. Now, simply mean that the area under that curve, which is both below and above, is just what? 1 square unit. So if you are having the question whether you are asked to sketch, you can sketch and see which areas are you calculating. You can see if you were to just go ahead and have the integral from 0 to 2 of y dx, our answer will have been different from the calculation we did, because we are going to just use the integral lower limit 0, upper limit 2. Then we perform our integration, and that will be wrong. So the curve will also tell you where you are moving from, your lower limit to upper limit. So that simply means that if I have a cubic equation that spans, let's say, from here, if this is the area A, B, let me enclose it, I have C. All this is going to be area of this plus this plus this. That is the actual thing. But because this is below, it's going to be area of this plus this minus this. So if I have A, B, C, D, and I have the function, it is going to be the upper integral from A to B of this function, which will be still y dx plus integral from where? C to D y dx, then minus integral from where? B, C, y what? Dx. So we can see that the upper area will be positive, as you can see. Then the lower area will be negative. We will delve into this aspect more in the next episode. Thank you so much for watching. Like, share, and comment. If you know somebody who may need this tutorial, share with them, encourage them to subscribe to the channel, and click on notification bell to receive notification anytime a video is uploaded. If you are new to this, subscribe. Thank you for watching. Bye-bye.